Okay, so P10.5, using conservation of momentum. Last lesson you were showing one of the important conservation laws, and that was conservation of momentum. And all that was what you have total momentum before. Remember, the symbol for momentum is rho, equals the total momentum after. Okay, and now we're going to start using that. Okay, but first of all, let's pop that into an equation. So in the last lesson I said the momentum depended on two factors. Those two factors were mass and velocity, which means that the total momentum before is the total mass before and the total velocity before, and that's going to equal the total mass afterwards and the total velocity afterwards. And you can do this in different ways. You can use an M1 and M2, or a before or an after. I like to use 1s and 2s, or you could use total before, total after, however you want to do it. Okay, so let's go for an example and then it will all make sense. Let's say that I have a car, and my car hits another car. Now, this car is travelling at 20 meters per second, and this car is travelling at, it's not travelling at all, it's stationary, so it's got 0 meters per second, it's not moving. This one it is. This one's got a mass of 1,000, and this one's got a mass of 2,000. Okay, so I now need to put that into my equation, because what's going to happen is this car is going to smash into this one, and then the two of them are going to go off together, because it's going to go into the back of it, and then they're going to go off together. Okay, so my momentum before is these two, the momentum of these two added together, so that's 20 times by 1,000. Add 0 times 2,000. So that's just my momentum that I had before from car 1 and the momentum I had before from car 2, and you just add the two together. I would use brackets here, even though you don't need them. I would use them just to make it clear what you're talking about. So this is car 1 momentum, this is car 2 momentum, and all you've done is add the two together. Okay, and that is going to equal this total momentum afterwards, but you don't know what that is yet. But you do know that it's going to be the mass of both cars added together, so mass 1 add mass 2, times by whatever their new velocity is. Okay, and that's their final velocity of the two combined. So that's the combined mass, and that's going to be what's the final velocity of the two vehicles combined together. So if I do this, well, I can see straight away that I've got a 0 there, so I can cancel this one out. Not moving, 0 momentum. It's not hard to stop something that's already stopped. So this is going to be 20,000 equals 1,000 add 2,000 times by V, which means that V equals 20,000 all divided by 3,000. Okay, so the first thing that I'm going to do there is I'm going to cancel out my zeros. So now I get 20 divided by 3, which tells me it's roughly 7 meters per second. It's going to be slightly less than 7 meters per second, but close enough for now. And if I want to sense check that, I can see that that makes sense, because 7 meters per second is less than 20 meters per second, and now I've got 3 times as much mass as what I had previously, so I should have about 1/3 as much of the original velocity. So I've got 3 times more mass, and I do. So I'm happy with that from a sense check point of view. Okay, so let's do an example where the first car is actually moving this time. So I've got 2 cars again, and this car is doing 20 meters per second again, just to make it easy, and this one is doing 10 meters per second. Okay, and this one has a mass of 1,000, and this one has a mass of 2,000. So I set it up in exactly the same way. I want to know what my total before is. It's the most important thing. What's my total before? So total momentum before is going to be 20 times 1,000, add 10 times 2,000. And again, just use brackets just to be safe. And then when they hit, when this one actually goes into the back of this one, they're going to go off together again. So I know that it's going to be mass 1 add mass 2, because they've joined their masses together, and they're both going to be going off at the same velocity, and that's going to be my final velocity, and that's what I'm going to try and work out. Okay, so put the numbers in. So I'm going to get 20,000 add 20,000 equals 3,000 V, which means that V is going to equal 40,000 all divided by 3,000. Cancel out my zeros, so I get 40 divided by 3. Well, it's roughly twice as much as what I had last time, so I know that that's approximately 14. Approximately. Okay. Which makes sense because this one's slowed down, but it's not slowed down by as much as what it did last time, because this one was also travelling in this direction, so you have to take into account that one's momentum. So that makes sense. Okay, and the final example of the two cars is what happens if you have one car going in one direction and the other car going in the other direction, and an explosion. So we've got two more examples. I would do those in part 2.